Hi. Hello, everyone. So my name is Senko Rašić, and today I'm going to talk about online audio and online video, how to record it, how to stream it, how to publish it, and how to watch it. And we're going to do it using open source, free software, and open standards. So I don't know if you know this, but online video is everywhere. It actually accounts for about 75% of all internet traffic. And when you're watching Netflix shows or just scrolling through your Facebook or Twitter feed or just watching YouTube or browsing online, you're probably seeing dozens or hundreds of video clips each day. Online audio is as well very widespread. I don't have the traffic figures, but for example, last year in the US, it consisted of two-thirds of all music revenues. So this just counts the paid streams and doesn't count all the free radio stations that people put online. So both online audio and video, internet radio is very popular, and it's not just easy to watch or listen, it's easy to produce, to go online, to record yourself, to be in front of millions of people. If you're a user of Facebook or YouTube or Instagram, their apps allow you to just tap on a few buttons on their apps and you're live, and millions of people can see you. And all is fine and well if you want to live inside a walled garden, if you want to use a platform that limits what you can do. So these platforms, of course, have limits on what you can do with your content. They limit your viewers what they can do. They track everything you make, so everything you do. So every play, pause, seek, rewind, every interaction with video is tracked and analyzed. The platforms may put up ads on top of your video or around it that you may not agree with or that you don't want. And of course, they can just take down your content if they deem it unsuitable for their platform. So as an alternative, if we want to avoid this, if we want to do our own solution, if we want to use open source, free software, and open standards, there is a bunch of technology out there that we can use, and in this talk I'm going to show you where to start looking. So this talk is more about which questions to start asking, where to start looking, and not just giving definitive answers. So when I'm talking about online video, I'll just first like to say what I'm meaning. So in the context of this talk and how online video is usually defined is a video or audio that is produced and published for somebody else to watch over internet. So this is pretty generic and hazy, but I'm going to say what online video in the context of this talk isn't. So I'm not going to talk about real-time communications, so video calls, audio calls, something that requires interaction and low latencies. This also doesn't cover video that's maybe transported over the internet, for example, OTT, television using internet, or monitoring cameras, CCTVs, and stuff like that. This also doesn't cover torrents of movies and TV shows. So in the context of online video, we basically have two types of content. This is live and on-demand. Live content, live video is video that is being recorded and then watched in real time as it is happening. For example, this conference is recorded, but also live streamed. So hello, live stream viewers. So live stream is a type of video where people join in, tune in, and then watch the stuff as it is happening. As opposed to this, we have video on demand or pre-recorded video, which is recorded, published, and people can just watch it whenever they like. For example, the YouTube clips, Netflix videos, and so on. So here's an overview, a very simplified overview of how live video production is done. So basically, first we have cameras and microphones on the scene recording sound and video. Then this video data and audio data is compressed or encoded into something that's more manageable. So raw video, raw audio take up a huge amount of space, and we want to compress it as much as possible without causing too much quality degradation. So to be as best quality as we can, considering the storage and the bandwidth that we need to use. So as it is recorded and compressed or encoded, this stream is sent or streamed to the video platform, which can be somewhere in your own network, some other computer, or some third-party cloud platform. And this service is tasked with fanning out these video streams or audio streams to all the viewers, to all the listeners. So the main task that this video platform is doing is it must handle all the listeners or all the viewers that can come in. And this may be a daunting task. For example, the 2017 US presidential inauguration drew around 4.6 million live viewers. So it's a huge amount of bandwidth that this kind of service needs to support. And basically, this bandwidth is always the limiting factor in how much bandwidth you can use, which quality, which screen size, and so on of your content you can produce. And then we have the video players, who are either devices, smart TVs, mobile devices, native applications, or just web applications that show this content to the viewers. And when they are accessing this content from the live streaming service, they are not first downloading it and then showing. Instead, as the content is received, it is immediately shown to the user. So it's streamed instead of downloaded. So this is basically a simplified overview, and now I'm going to go a bit deeper into which protocols, codecs, formats, and so on are used. So a bit of buzzwords here. Basically, in context of online video, most protocols used are based on HTTP. This is in very stark contrast to real-time communications, which is mostly UDP-based for latency and other reasons. So basically, all the streaming protocols involved in online video or audio are some forms of HTTP extended in various ways. For example, to send the video from the encoder to the streaming service, most services use RTMP, which is a protocol devised by Adobe back in the day and now become de facto standard for sending video to the streaming service. Of course, if we have pre-recorded video or audio and we just need to upload it, we can use HTTP or FTP. And then to watch this or to listen, the players connect, again, using HTTP and some application protocol on top of it, and start receiving data. So nowadays, the most popular way to do it is HLS, which is HTTP live streaming. This was invented by Apple. This is a small extension on top of HTTP, which basically splits the content into segments, into, for example, 2-second segments, and generates a playlist, a text playlist. So the video player first downloads the playlist, and it has a lot of these segment files, and it knows which segments it needs to load. So it can seek around, move around to the end of the file, to the beginning, and so on. And this is also the way to implement live streaming, because this playlist is just updated constantly, and the player knows which new segments it needs to load. Dash is basically the same thing, but it's an actual standard as opposed to just Apple doing their own thing. HDS is something similar from Adobe. A lot of people have started using WebSockets to do video streaming, because WebSockets is a bidirectional communications channel between the client and the server using HTTP. So it's getting some traction in this use case as well. And we can also always use plain old HTTP. So with HTTP progressive download, the client, as it connects and starts receiving the file, it can immediately start showing it to the viewer. But with plain old HTTP, we cannot do seeking to the part of the file that hasn't been downloaded yet. We cannot do live streams, so it's not very popular. When looking at the codecs and formats, so the content of these streams, the content of this audio and video, how it's compressed, how it's packed, there's basically 2 codecs that are used by everybody in the industry today. This is, for video, it's H.264, and for audio, it's AAC, or Advanced Audio Codec. Both codecs are proprietary. They are not royalty-free. They are under patents, and although people promise they will never sue anyone for using these 2 for online video, it's just a promise. It's not legit, like some contract that can be relied upon. So alternatives for this, if we are talking about open standards and open codecs, the alternatives are VP8 and VP9 that were made by Google for video codec. VP8 is basically roughly equivalent to H.264. VP9 is the next generation, which is roughly equivalent in performance to the H.265, the next generation, next generation codecs. And on audio side, we have Vorbis and Opus codecs. And these two, so when you compress the stream, you have video parts, you have one or more audio streams, audio tracks, and then you want to combine all of these into one file or one stream to send. And this is the job of the container format. And the most famous or the most popular container format right now is, for video, is Ffmpeg or MP4 for video files. When we are doing online streaming, MP4 is not used because it's really optimized for files, not from streams. So for streaming, Ffmpeg transport stream or Ffmpeg TS is used. And a free and royalty-free and patent unencumbered format that's been used is WebM, which is Google extensions of Matroska MKV format. And if you're watching, for example, YouTube on Chrome or Firefox, you're going to be using VP9 plus Opus plus a WebM combination. So the free codecs and free formats. So as mentioned in this like alphabet soup of buzzwords and names and acronyms, there's a lot of codecs, there's a lot of formats, there's a lot of clients, there's a lot of platforms, and being able to reach as wide audience as you can be pretty tough if you want to use an open codec. Basically, today's situation is such that if you want to reach the most audience, you have to use H.264 and AAC. So this screenshot here is a screenshot from MDN, from Mozilla Web Docs, which outline the browser support for audio and video element in various browsers. And this is just half of the matrix. The other half for mobile is similarly complex. And most of these entries here also have footnotes, so they're predicated on some special support you have or don't have on your device. So basically, it's an iceberg scenario, and if you want to reach as wide audience as you can, you have to go with H.264 and AAC, which is unfortunate because both of these are not open, are not royalty free. But what we can do is progressive enhancement. So what we can do is try to serve VP9, Opus, WebM files to the audience, and if their technology, if their browser, if their device supports it, they will use this, and if not, we can fall back to the standards. And this is the approach, as I mentioned, that Google's using with YouTube. So if you're watching YouTube videos in Chrome or Firefox or Android devices, you're going to be using open standards. Of course, the entire industry is aware that it's not an ideal situation. I mean, the entire internet is based upon open standards, and here we have a situation where 75% of this internet traffic is using something that's not as open. So a bunch of industry players have come together and are in the process of defining a new video codec called AV1. They're just standardized it a couple of weeks ago, I think. So now, in the coming months and years, people will start writing optimized codecs and putting the support into hardware. And I hope maybe inside of 10 years, we won't have this situation. We'll be able to use an open codec for video as well. So this codec is not just good from perspective of that it is open, it is royalty free. It is also good from the performance perspective. So it's a much better performance in terms of quality with bandwidth used than the existing, but it's pretty new and the implementations right now are really slow, so it's going to take a long time for it to catch some speed. But enough about theory, let's actually try to do something here, right? I'm going to start with audio. So for the past 10 minutes, I've just talked about video, but let's start with audio first because it's easier. Nowadays, if you want to use free software and start your own, for example, internet radio station, you you will definitely want to use Icecast or Icecast 2. This is basically the go-to solution for creating internet radio stations or online audio. And it supports various codecs and formats. It, of course, prefers Vorbis Opus, but it can also handle MP3 and AAC if you want. So which codec to use here really depends on your listeners. If you know that your listeners can handle Vorbis or Opus, go with that. If you're not sure, use MP3 or AAC, or provide a couple of streams and then tell the users to just use the one that they prefer. In terms of how to generate, how to encode this audio stream, there's a lot of very high quality software that you can use. For example, Ffmpeg, which I'll feature a lot in this presentation, Music Player Daemon, VLC, EasyStream, GStreamer, and a lot of other software. In terms of which audio player to use, which music players to use, basically every player on the planet supports internet radio. So it's just connecting to HTTP, getting the data and playing. So if you know that your users are like Linux users or that they have Vorbis and Opus support, go with that. If not, go with, for example, for MP3 and you're all set. The situation with video is roughly similar but a bit more complex. So again, here we have cameras and microphones that record sound and video. We want to encode and compress that and send to the streaming platform. There's, again, Ffmpeg for encoding, but you can also use software like Cheese on GNOME or any webcam application to record from the video card or from webcam. We can use Obs Studio, which I'll talk about a bit later. And then we have to send this data somewhere to the video platform. And here we also have a few choices. We can go with a typical web server, Nginx, Apache, whatever. And if we are doing video on demand, so we already have video files prepared, we can use, for example, Ffmpeg to prepare HLS or Dash playlists. So this split the video file into small segments, creates a playlist, and then you have a bunch of files on the disk, and you can serve it any way you like. Or you can use, Nginx has a RTMP plugin, which can ingest RTMP and output RTMP and HLS, so you don't have to do this preparation, and you can do live streaming with Nginx. There's also Red 5. Red 5 is a pretty old piece of software already that started as a clone of Adobe Media Server. So it's Java-based, and it can support RTMP and a lot of other protocols. And somewhat newer fork of Red 5 is Ant Media Server, which makes some things much easier. For example, it has a web-based, nice graphical interface, so you can just click a few buttons and off you go. And then this can be then played by various media players on Linux or other platforms that you might be using. For example, in a browser, HTML5 audio, video, VLC, GNOME KDE, or other media software that you are, or software from other desktops that you are using, MPlayer, GStreamer. So in terms of software, there's a lot of choices here. You just need to have all these codecs and formats matched in terms of what you want to send and to watch. So let's actually start to record something. So these are two examples. One is using graphical user interface, and one is using the command line. So whichever you prefer, you're all set. Here I'm using just the built-in webcam app that comes with GNOME, so Cheese, which can record pictures, but also it can record video. And on my Debian 9 machine, it records in VP8 and Vorbis. But I think I could tell it to use VP9 and Opus as well. So it just really click and play or click and record. If you haven't used Ffmpeg before, it can be really daunting. Ffmpeg is basically the Swiss Army knife of multimedia on Linux. It can do basically everything. And a lot of third-party services and media companies and so on probably use Ffmpeg at some point in their pipelines. So in this example, I'm using Ffmpeg to take the video from the video card, from audio card. From outside, I'm using audio, and I'm telling it to encode into VP9 video codec and Opus audio codec and put it in WebM container. Since we might have to handle multiple players which have multiple codec supports, maybe some people are on internet connections that have more bandwidth or less bandwidth, we might want to convert or transcode the videos into smaller formats or different formats. If you like using graphical user interfaces, I recommend Handbrake, which is a pretty nice tool to just convert video from anything to everything. And if you prefer command line, again, Ffmpeg is your tool of choice. You just tell it what to convert it into, and it'll do the job. Live streaming, again, Ffmpeg, surprise. But also Obs Studio. Obs Studio is a very nice piece of software that combines mixers with video encoding. So you can define multiple input streams of video and audio, maybe static pictures. You can easily switch between them or combine them, so you can basically have a mini studio. And it can record or send this to the streaming service. Or, as I mentioned, if you're a command line guy or girl, use Ffmpeg to grab the video and audio and then send it via RTMP to the streaming service. For live streaming, as mentioned, we will have to have the server component, and we can use RTMP modular with Nginx. We can use Red 5, and in the experiments and in the work that I've been doing, I like Ant-Media server. So both Red 5 and Ant-Media have free software community editions and paid editions, which you have subscriptions for and so on. But the open source free software editions are pretty capable, and I'm just focusing on them here. So, and it's also Java-based, so you don't even need to install it. You just unpack it, store the servers, connect with your browser, define a few parameters, and you can start streaming. So it's really, really easy to get started with. And on the video player side, if we are thinking about playing this in a browser, browsers all support video and audio, so we can just have a single HTML tag and off we go. Or we can use some JavaScript player that has some additional features and builds on top of this built-in video tag. For example, the most popular right now is, most widespread is Video.js. And if we're using native applications, desktop applications, we can use VLC, Kodi, your media player of choice, MPlayer or MX Player or whatever. But the biggest problem here is not the software, it's the hardware. So as you can remember, the amount of viewers, the number of viewers that can connect to your stream are taking up resources, network resources, CPU resources. So when thinking about the audience that will listen to or watch your stream or your content, you need to think very carefully about how much bandwidth you need, how much storage you need, what your cost is going to be, and so on. So this hardware and infrastructure bit is the hardest bit when you're trying to do online audio, but especially video by yourself. And like to conclude, let's see how DOORS, this conference, is doing. So this conference is being live streamed by Carnet, by their Medusa service, and they are using H.264 NAAC. This is not surprising since they want the content to be as wide-reaching as possible. Again, standard setup. So H.264 AAC using HLS, so HTTP live streaming with Ffmpeg TS. For video on demand, they're using Nginx. For live streaming, also Nginx, but it might be something in front of it which is not visible to when you try to inspect it. And on the front end, they're using also HTML5 video and open source JW video player. So this talk is basically a small recap of if you want to do online or video or audio streaming, what software do you use, which are the topics, which are the problems. And my intention here is to give you questions and starting points so you can research and see what you want to play with. Thanks. So we've got time for a couple of questions. If anyone wants to ask something. No? Okay. Well, thanks again.